What if everything we thought we understood about the universe turned out to be wrong? That's the question we're grappling with today as we delve into a recent unexpected discovery that has astronomers and cosmologists scratching their heads in wonder and disbelief. The James Webb Telescope, our most advanced eye in the sky, made a shocking discovery. It found a massive, mature galaxy that existed around 13 billion years ago. This is not just surprising, it's downright perplexing. Why? Because our current cosmological theories did not predict such a galaxy could exist at that time. Imagine the universe as a giant cosmic theater. In its early scenes, according to our theories, galaxies were just starting to form. They were small, nascent entities, slowly growing and evolving over billions of years. But this newly discovered galaxy, it's like an actor who showed up fully dressed and rehearsed for the final act, while the play was barely underway. This galaxy is not just mature. It's massive. It's like finding a skyscraper in the middle of a primitive village. It doesn't fit with our understanding of how galaxies form and grow. It's not supposed to be there, not according to the script we thought the cosmos was following. This discovery is exciting, but also unsettling. It challenges what we thought we knew about the universe's history. It implies that either our theories are wrong or something else, something we haven't considered yet, is going on. It's a cosmic curveball, a puzzle that scientists are eager to solve. So, where does this leave us? Well, in a state of delightful confusion. This unexpected finding has opened up a Pandora's box of questions about our universe. It's a reminder that the cosmos is full of surprises, and we're just beginning to uncover its mysteries. As we peer deeper into the universe, who knows what else we might discover? It's a thrilling time to be exploring the cosmos as we continue to question and refine our understanding of the grand cosmic theater we're a part of. This finding opened up a Pandora's box of questions about our universe. Uniformity and isotropy, long-standing pillars of cosmology, are now under scrutiny. For centuries, scientists have assumed that the universe's spatial matter distribution is uniform and isotropic. This means that, on a large scale, the universe looks the same in every direction and from every point. It's a principle that has informed our understanding of the cosmos and guided our research. However, recent findings are challenging these assumptions. A study published in the astrophysical journal Letters on the 6th of February has thrown a wrench into the works. The research suggests that the universe's expansion rate may not be uniform after all. Instead, it could vary depending on where you're observing from. This is a startling revelation. We've long believed that the universe is expanding at a consistent rate in all directions. It's a comforting idea, isn't it? That no matter where we are in the universe, the same fundamental rules apply. But if the universe's expansion rate varies, our understanding of cosmology may need a significant overhaul. The uniformity and isotropy of the universe have been cornerstones of cosmological theories. They've helped us make sense of the vast, seemingly chaotic cosmos. They've allowed us to predict the behavior of distant galaxies, to measure the age of the universe, and to explore the mysteries of dark matter and dark energy. But what if these cornerstones are not as solid as we thought? What if the universe is more varied, more diverse, more complex than we've imagined? It's a daunting prospect, but also a thrilling one. It means that there's still so much to learn, so many mysteries to unravel, so many questions to answer. As we delve deeper into the cosmos with tools like the James Webb Telescope, we're bound to uncover more surprises. And each surprise is an opportunity to expand our knowledge, to refine our theories, to get a little closer to the truth. Could it be that the universe's expansion is not uniform, as we previously assumed? If so, we're on the brink of a new era in cosmology, one filled with fresh insights and exciting discoveries. The Hubble constant, a key factor in determining the universe's age, is now a hotly debated topic. This constant is essentially a measure of how fast the universe is expanding. But recent studies have thrown up some puzzling discrepancies in our calculations of this constant, which have far-reaching implications. Traditionally, the Hubble constant has been used to suggest a uniform expansion rate for the universe. This is based on the notion that the universe's spatial matter distribution is uniform and isotropic. However, recent findings are questioning this assumption. Researchers are now finding that the universe's expansion rate might vary depending on where you're observing from. This is a significant departure from the assumption of a constant expansion rate and poses a challenge to our understanding of the universe's age and nature. To add to the complexity, different methods of measuring the Hubble constant are suggesting different ages for the universe. For instance, measurements from the Hubble Space Telescope have indicated that the universe could be as young as 9.7 billion years, or as old as 19.5 billion years. That's quite a discrepancy. Meanwhile, observations of the cosmic microwave background radiation suggest a Hubble constant of roughly 67 kilometers per second per megaparsec. On the other hand, measurements from Cepheid variable stars indicate a constant closer to 74 kilometers per second per megaparsec. These conflicting figures are causing a stir in the scientific community. They suggest that our understanding of the universe's expansion, and therefore its age, could be fundamentally flawed. This has led to what Nobel laureate David Gross describes as a cosmological crisis. So we find ourselves in the midst of a fascinating debate. The Hubble constant, once seen as a definitive measure of the universe's expansion, is now under scrutiny. And as we grapple with these discrepancies, we're forced to question some basic assumptions about the universe's nature. With such diverse measurements, could our understanding of the universe's age be fundamentally flawed? This is the question that has been thrust into the limelight, and it's a question that is driving a new era of cosmological exploration. Could the key to understanding these discrepancies lie in the dark energy that pervades our universe? Dark energy, that elusive force that makes up about 70% of the universe, is believed to be the driving force behind the universe's accelerated expansion. But what if it's not as uniform as we've assumed? This could provide a compelling explanation for the varying expansion rates we're observing. Imagine the universe as a loaf of raisin bread dough. As it bakes in the oven, it expands, and the raisins, representing galaxies, move away from each other. Now, if the yeast, our metaphorical dark energy, is evenly spread throughout the dough, we'd expect all the raisins to move apart at the same rate. But what if the yeast is clumpy? Some raisins would then move faster than others, mirroring the differing expansion rates we see in our universe. This possibility of non-uniform dark energy could reconcile the conflicting measurements of the Hubble constant. If dark energy is denser in some areas of the universe, it could cause those regions to expand more rapidly, which would affect the Hubble constant measurements based on observations in those areas. The cosmic microwave background radiation suggests a Hubble constant of roughly 67 kilometers per second per megaparsec, while measurements from Cepheid variable stars suggest a higher rate of 74 kilometers per second per megaparsec. If dark energy is indeed variable, these differing measurements could be snapshots of the universe's expansion at different points in time and space, rather than conflicting data. The implications are profound. If proven, this would radically alter our understanding of dark energy, the universe's expansion, and indeed cosmology itself. But more investigation is needed before we can rewrite the textbooks. The James Webb Telescope, with its unprecedented resolution and sensitivity, will undoubtedly play a pivotal role in this exploration. The mysteries of dark energy may hold answers to our cosmological conundrums. Nobel laureate David Gross describes these inconsistencies as a cosmological crisis. The recent findings have rattled the very foundation of our understanding, raising perplexing questions about the age and nature of the universe. For a century, we've believed in a uniform universe, a cosmos that behaves the same regardless of where we look. But the discovery of a massive, mature galaxy existing around 13 billion years ago, far earlier than expected, has challenged our standard cosmological theories. Moreover, studies suggest the universe's expansion rate isn't as uniform as we once thought. Depending on where we observe from, the rate seems to vary. This inconsistency has sparked intense debates and led some to question whether our current cosmological model is even accurate. One of the most glaring issues is the Hubble constant, a value intended to determine the universe's age. Discrepancies in its measurement have led to wildly different age estimates, ranging from as young as 9.7 billion years to as old as 19.5 billion years. Meanwhile, the cosmic microwave background radiation suggests a Hubble constant of roughly 67 kilometers per second per megaparsec, contrasting sharply with the 74 kilometers per second per megaparsec derived from the Cepheid variable star measurements. Such a stark difference has left scientists scratching their heads. Then there's the dark energy variable. Could it be that dark energy, the enigmatic force driving the universe's expansion, is not uniform across the universe? If so, this could explain the different expansion rates we're observing. It's clear that we're in the midst of a cosmological crisis, one that may require a paradigm shift in our understanding of the universe. It's a crisis that invites us to question, to explore, and to seek new answers. Today we find ourselves at a crossroads in our understanding of the universe, and the path forward is as mysterious as the cosmos itself.